This video is an exercise 9D question 3. So we have a fenced triangular plot of ground which has area of 1200 meters squared. The fences along the two smaller sides are 60 meters and 80 meters respectively, and the angle between them is theta. So first we want to show that theta is equal to 150 degrees, and then we want to find the total length of fencing. All right, so first of all, since the goal is to find the angle first, let's just draw the triangle. So we essentially have a triangle that sort of looks like this, and here is theta, and then here is 60 meters, and now 80 meters. We also know that the area is 1200 meters squared, and now we first want to find theta. So we can simply use the very useful formula of area of a triangle is equal to half AB sine theta, where theta is the angle in between of A and B, which is exactly the case here. So we can just plug in the values into the formula. So we have half times 60 times 80 times sine theta, and now we just rearrange this. So we essentially get sine theta is equal to a half, and now we just take the arc sine of both sides to find the value of theta, and there are two possible values. So one is 30 degrees and the other one is 150 degrees. So we also want to show that theta is actually equal to 150 degrees. So here we just need to give a very simple reason. And when we look at the triangle, so we can obviously label that. So let's say here is A, B, let's see. Now, here the interesting thing is that we obviously know that theta is in between AB and AC, right? Because we were told that. So therefore, BC is the largest side. So theta must be the largest angle as a result of that. Because just think about this. If theta is 30 degrees, then that's not definitely the largest angle, and as a result of that you're not going to get the largest side, right? So that's basically the logic that we can simply say that as BC is the largest side, thus theta is or maybe must be the largest angle. So therefore theta is equal to 150 degrees. And then for the next one, we want to work out the total length of fencing. So that just means that find a perimeter. Now, to find a perimeter, we first need to find BC. And we can now find BC by using the cosine rule, because this is just the perfect condition for the cosine rule, because we want to find one of the lengths and we have basically two of the lengths and the angle in between of them. So in this case, BC squared is simply equal to 60 squared plus 80 squared minus 2 times 60 times 80 times cos 150. That simply gives us BC. So the value of BC, once we solve this, so I'm not going to write all the just calculation in detail here because I think it's obvious. We'll get the value of BC to three significant figures as 135 meters. So now that we have BC, then to find the perimeter, we just add all of these basic 135 plus 80 plus 60, which is 275 meters to three significant figures. So that's the perimeter.